This week, we're going to be tackling geometric construction. We've got a bunch of great materials, all designed to help us not only understand the concepts ourselves, but also, and this is key, figure out how to teach them effectively. That's the goal. As I was going through the material for this week, one of the things that really struck me, it's this idea that creation itself, whether it's a building or a painting or even a mathematical proof, right, reflects the image of God. And there's this one quote that stopped me in my tracks when I read it. It says, our creations reflect truths. Material constructions represent eternal and divine truths. I'm going to toss that to you. What resonates with you about that idea? What pings for you when you hear that?
Well, the first thing that comes to mind is the precision and intentionality. They're talking about Noah's Ark and the tabernacle, right? These are huge, elaborate structures. They weren't just thrown together. They were carefully planned, carefully built. And it's the same with geometric constructions. We're not just doodling here. It's about understanding principles and applying them carefully to create something precise, something true.
It's like we're tapping into this deeper order, this kind of universal language.
There's a beauty in that precision, in that order.
I totally agree. Okay, so you know me. I always like to think about the practical side of things, right? How does this apply to the real world? And the material mentions a few things. Line art, daisy wheel, and optical art. Are those just fancy terms?
Oh, no. Those are real things. And they all connect back to geometric constructions in really cool ways. Think about the golden spiral, for example. It's this beautiful spiral. You find it in seashells, in galaxies, even in the proportions of the human body.
Really?
It's derived from geometric principles, and artists and architects have been using it for centuries to create this sense of harmony and balance.
So we've got this connection between geometry, art, and faith, and we're seeing how it plays out in the real world. But let's get down to brass tacks here.
Okay.
Our listeners are busy homeschool parents. They need practical tools, right? So let's look at some of the quiz questions that are in the material, because those are designed to help you, the homeschool parent, confidently tackle these lessons with your kids. So here's one. How does the act of creation reflect the relationship between humanity and God? How do we even begin to answer that with our kids?
Well, it starts with understanding that we're made in God's image. And part of that image is the ability to create. Just like God created the universe with order and purpose, we can create too, using our knowledge of math and geometry.
So it's like we're reflecting that divine act when we create something, whether it's a geometric construction, a piece of art, a meal.
It's all creation.
Whatever it is, right? It's all creation. Yeah. Okay, here's another question that I think might be a little bit tricky for some of us. Explain the concept of dimensions in mathematics, providing examples.
Dimensions are all about how we measure the extent of something. A point has no dimensions, it's just a point. A line has one dimension, length. A square has two dimensions, length and width. And a cube has three, length, width, and height.
Oh, so it's like adding layers of complexity.
It's like building up from a simple point to something more complex.
So we've got these big ideas, and then the material also gives us a glossary of terms. And let me tell you, there are a lot of them.
There are, yeah. Geometry's got its own language, for sure.
Out of all those terms, is there one that you would say is most important for parents to focus on this week? If they can grasp this one term, they'll be in good shape.
I'd say the most important one is construction itself.
Why that one?
Because it's the foundation of everything we're doing this week. When we talk about construction and geometry, we're not just talking about drawing. It's about creating figures using only a compass and a straight edge, no measuring. It's about understanding the relationships between points, lines, and angles, and using those relationships to build the figures.
We're not just drawing shapes, we're actually discovering them.
We're discovering their inherent properties through the process of construction.
It ties back to that idea of creation reflecting the image of God, doesn't it?
It does. We're participating in this creative process that's based on order and precision, just like God's creation.
And it's fun. Who doesn't love playing with a compass and a straight edge?
It's like art and math all rolled into one. All right, so the source material has some really cool quiz questions that really get into those practical techniques. And remember, these questions aren't just for your kids, they're for you too, right?
Right.
To help solidify your own understanding so you can confidently guide your homeschoolers.
One question that caught my eye is, describe the basic steps involved in constructing a circle using a compass.
It seems pretty straightforward, but there's actually a lot going on there.
I know how to draw a circle, but constructing it feels different somehow.
It's not just about drawing a circle freehand. It's about using those tools and techniques based on those mathematical principles.
So walk me through it. What are the steps?
So first you fix the point of your compass,
Okay.
where you want the center of your circle to be.
Right.
That becomes your anchor, your starting point. Then you adjust the compass to the desired radius.
So that's the distance from the center to the edge of the circle, right?
Yes. And then keeping that radius constant, you gently rotate the compass 360 degrees around that center point.
And boom, you've got a perfect circle.
There you go.
Let's move on to another question, which asks about patty paper.
Patty paper.
Yeah. What is the purpose of patty paper in geometric constructions?
I know this might sound a little unexpected,
A little bit, yeah. I use patty paper for baking, not geometry.
but in geometry, patty paper becomes this amazing tool for visualization and manipulation.
How so?
Well, because it's translucent, you can see through it, which is super helpful for certain constructions. You can fold it to create perpendicular bisectors, angle bisectors.
You can.
Oh, yeah. All sorts of things. You can trace lines, shapes, and overlay them to see how they relate.
It's like hands-on geometry.
It is. It makes it come alive for kids.
Okay, so we've got compasses, we've got patty paper, and now let's move on to a question that might trip up some folks who, like me, are not geometry whizzes. Explain the difference between a circumscribed circle and an inscribed circle.
It's easy to do. So imagine you have a polygon, like a triangle. A circumscribed circle is a circle that goes around the outside of that polygon, passing through all its vertices.
Corners.
Yes, the corners.
Okay.
And an inscribed circle is a circle that fits snugly inside the polygon, touching all the sides.
So circumscribed is on the outside. Inscribed is on the inside. All right, let's tackle one more. What are the essential tools required for compass and straight edge constructions?
We only need a compass, a straight edge, a pencil, and paper.
That's it.
That's it. With just the simple tools, you can construct a whole world of geometric figures.
I think we have time for one last question before we wrap up this segment. This one asks us to define tessellation and provide examples of regular and semi-regular tessellations.
Oh, tessellations. They're so visually appealing. So a tessellation is basically a pattern of shapes
Okay.
that fit together perfectly.
Without any gaps or overlap.
Think of a tiled floor.
Or a honeycomb. Nature's full of them.
Now, a regular tessellation uses only one type of regular polygon.
So a polygon where all the sides and angles are equal.
Precisely, like a square or a triangle.
Yeah.
And a semi-regular tessellation uses two or more types of regular polygons arranged in a pattern.
So squares and octagons fitting together.
Or triangles and hexagons.
It's like a geometric puzzle.
And they all fit together seamlessly.
I love how tessellations connect math and art so beautifully.
Me too. They're like little works of art.
Okay, I think we've covered a lot of ground in this segment. Tools, techniques, even tessellations.
We have been busy, but there's still so much more to explore.
Oh, I know. I'm already excited for our final segment. We're going to dive even deeper into the connections between geometry, art, faith, and the nature of reality itself. And I had to say, I am so excited about this last part,
This is where it all comes together.
right? We've explored the tools and techniques, but now it's time to get philosophical. The source material includes these amazing essay questions that really make us think about the why behind geometric construction.
I love a good essay question. They really force you to go deeper.
They do. And these questions aren't just for students, they're for all of us, especially as homeschool parents.
Absolutely.
Because they help us understand the bigger picture, which makes us better teachers.
So which question are we tackling first?
Okay, here's one that really got me thinking. Discuss the symbolic connection between geometric constructions and God's act of creation.
Big implications there.
It's deep. It also asks, how does this connection enhance your understanding of both mathematics and faith?
You know, we've been talking about how these constructions require precision, intentionality, and an understanding of principles. And those are all qualities we see reflected in God's creation too.
Yes. The source material talks about how God is the ultimate creator.
Right.
And we, as humans, made in his image, we have this spark of creativity in us.
And when we do things like geometric constructions, it's like we're tapping into that spark. We're not just drawing lines and circles. We're participating in this act of creation that mirrors the order and beauty of the universe.
It gives a whole new meaning to math class, doesn't it?
It really does.
Helping them see the world through this lens of divine order.
And by understanding those principles of geometry,
Yeah.
we get a deeper appreciation for the elegance of God's creation.
Okay, let's look at another essay question. This one asks, analyze the role of geometric art in exploring mathematical concepts. It also asks, how can artistic expression deepen our understanding of geometric principles?
Well, think about all the incredible examples of geometric art throughout history, like the intricate patterns in Islamic art
Oh,
or
yeah.
the mind-bending work of M.C. Escher.
He was a master.
He was. He used geometric principles to create these incredible illusions, playing with perspective and symmetry. And those art forms, they not only demonstrate those mathematical concepts, they invite us to explore them, to really see their beauty and potential.
Maybe even create our own geometric art. Okay, ready for our final essay question. Explore the concept of the unseen in the context of geometric constructions.
Okay, the unseen.
It goes on to ask, how does the ability to imagine and construct geometric figures relate to our understanding of abstract concepts and the nature of faith?
It's making me think about how we take something that's intangible, like an idea, and make it visible through construction.
Like when we construct a circle, we start with this concept in our mind. The circle doesn't exist yet, it's unseen. And then, using our tools and knowledge, we bring it into the physical world.
It's like we're giving form to the formless.
And I think that process really mirrors our faith journey, doesn't it?
We grapple with these concepts that are hard to grasp, like infinity or the nature of God.
Right.
They're unseen, but through faith, we come to understand their reality.
And geometric constructions, in a way, they offer a similar experience.
They do. They allow us to explore these concepts that go beyond what we can see and touch.
Concepts that require us to use our imagination and our reasoning.
And our faith in those underlying principles. So to all our listeners out there, as you embark on these mathematical adventures with your kids, remember this. Every circle you draw, every line you construct, it's a testament to the power of human creativity.
And a reflection of that divine order that permeates the universe. Keep exploring, keep questioning, keep discovering that joy and wonder of geometry.
Yes.
And keep nurturing those sparks of creativity and faith in your children. Well, that's it for our deep dive into geometric construction. We'll see you next time for another exciting exploration.
Bye, everyone.